Hello friends, all the students appearing for TYBSA students appearing for the SPPU MCQ examination to be conducted in October 2020. In this second video, we will go for some more problems, basically multiple choice questions based upon chapter number 4, 5 and 6 in thermodynamics and statistical physics. I must thank Dr. Suranda Pisa ma'am, Honorable Head, Department of Physics, SN Joshi College, Hadapsar, for providing these important questions for discussions with you. Now let's go for question number first, that is question number 28 in the series. First one is, a microstate is defined as state of system specified by its pressure, volume V, temperature T and energy E. First option. Second is a combination of position space and momentum space. A state of system in which we specify the state of all constituent particles. Option 4, the collection of large number of identical systems having different microstates but belonging to the same macrostate. So here first we should understand the basic meaning of the term we used in that is phase space. So in phase space we have momentum coordinates and the position coordinate x and px, one dimension. In three dimensional we have three position coordinates and three momentum coordinates. So in such a phase space, when we define a coordinate of all one of the point, single point, by all its coordinates, space coordinate as well as its momentum coordinates, this is called as the microstates. So here the option 3 is correct option for question number 28. A state of system in which we specify the state of all constituent particles. So depending upon how many number of particles are there, we are going to specify its position and momentum coordinates specifically. That is called as the microstate of the system. So question number 28 option is 3. Then question number 29, a macrostate of system is defined as option 1, state of system specified by its pressure P, volume V, temperature T and energy E. Option 2, a combination of position space and momentum space, which have already we called is to be a phase space. A state of system in which we specify the state of all constituent particles. This is what already we have seen. This is called as, actually this is phase space. Second, it is phase space. Then this is the microstate. And third one is a collection of large number of identical systems having different microstates but belonging to the same macrostate. So this is the actually definition of statistical ensemble. So here we'll find that the option 1 is most correct option. So it's state of system specified by its pressure P, volume V, temperature T and energy E. So that is what it is. This is called as the thermodynamic variables. So option 1 is correct option for question number 29, which is called as a macrostate. So we must understand the difference between microstate and macrostate. In microstate we define we specify the position and momentum coordinate of a single particle, or if a system consisting large number of particles. So for each one, when we go for describing its position and momentum coordinates, that is called as a microstate. And macrostate is the where we are having different types of thermodynamic parameters are specified for a system. So that is called as a macrostate. Question number 30, phase space is defined as already we have seen. So here this is the correct option is 2, that is a combination of position space and the momentum space. Already we have discussed all these things there. Then statistical ensemble is defined as, again options are just same, but here the first option represents a macrostate, second option represents a phase space, third option represents a state of system in which that is called as the microstate, and therefore option 4 is correct. A collection of large number of identical systems having different microstates but belong to the same macrostate, that is called as the statistical ensemble. So this is the actual definition of statistical ensemble. Then question number 32, accessible macro state is defined as. Accessible means where these states can be occupied by the particles. So state of the system specified by its pressure, volume, temperature and energy, that is what called, already we have called the macro state. The macro state which are allowed under constraints. So certain constraints are there, and under that constraint certain energy levels are available or states are available. So such states are called as macro states or accessible macro states. So option 2 is correct. Option 3 and 4, a state of system in which we specify the state of all constituent particles, that is microstate, and the microstates which are not allowed under the constraint. So both of these options are not correct. So correct for option for this question number 32 is the macrostate which are allowed under constraint. Then inaccessible macrostate is again as clear as like this. So the state of system specified by its pressure, volume, temperature and energy, that is not correct. The macrostate which are allowed under constraint, that is accessible macrostate. The state of the system in which we specify state of all constituent particles, that is also not correct. So the correct option is this 4, that is the macrostates which are not allowed under constraints. So such macrostates are called as unaccessible or inaccessible macrostates. Question number 34, which of the following is a macroscopic variable? So macroscopic variables like pressure, volume, temperature, and energy, entropy, etc. all these are macroscopic variables. So therefore question number 34, option 4 is correct, all of the above. Then question number 35, which of the following is the correct expression for the entropy? And this is what called as the Boltzmann formula for entropy. So S is equal to K omega E, S is equal to K times ln omega E, S is equal to ln omega E, and S is equal to ln K. Out of that, question 2 is most correct. So this is what entropy S is given by K, that is called as Boltzmann constant, into log of omega of E, that is called as the accessible states or density of the states. So S is equal to K ln omega is the correct expression for the entropy, which is called as the entropy of the system. Then question number 36, what is the postulate of equal priori probability? So here options are as follows. Number 1, all accessible microstates corresponding to possible macrostates are equally probable. All accessible microstates corresponding to a possible macrostates are not equally probable. Probability of state of system can be found, and none of this. So this is the actual definition of this a principle of postulate of a equal priori probability, that all the accessible macrostates corresponding to a possible macrostates are equally probable, and that is the that's why option 1 is the correct for question number 36. 37, microcanonical ensemble is an ensemble in which its system has the same fixed energy as well as same number of particles. A system can, option 2, a system can exchange energy but not matter. A system can exchange both energy and matter, and none of the above. So here macrocanonical ensembles are there wherein no energy is allowed to exchange. Okay, energy not allowed to exchange, as well as the mass of the particle exchange is also not allowed. So such type of ensemble are called as the microcanonical ensemble, and therefore option 1 is the correct option for question number 37. Then in canonical ensemble, question number 38 is an ensemble in which each system has same fixed energy as well as same number of particles. That is what already we have seen, microcanonical. Number 2 option, system can exchange energy but not matter. So this is the correct definition of the canonical ensemble, where energy is allowed to exchange between systems but matter is not allowed to go from system 1 to system 2. That is this. And third one is the system can exchange both energy and matter. That is what called as the grand canonical ensemble. So question number 38, option 2 is the correct option. Question number 39, grand canonical ensemble is an ensemble in which, as well already we have seen, both the system can exchange both energy and matter. Therefore option 3 is the correct for this. So remember, canonical, so first it is microcanonical, then second is canonical ensemble, and third is the grand canonical ensemble. And ensemble, and here, as we say, here in the first case neither energy nor mass is allowed to exchange. Here in this case energy is allowed to exchange but no mass is allowed to exchange, and here in this third case energy as well as mass both are allowed to exchange. So that difference is understood. We can classify the systems or the ensembles on the basis of these three things. Question number 40. Now symmetric wave function is a wave function in which on interchanging any pair of identical particles there is no change of sign of wave function. On interchanging any pair of identical particles, sign of wave function changes. So actually option 1 and option 2 are opposite to each other. So therefore option 3 is not to be there, not correct at all, as well as option 4 is also not correct here. So symmetric wave functions are said to be wave functions which do not change their sign even though we change the pair of the identical particles. So question number 40, option 1 is the correct one. Now 41 is exactly opposite to this. Anti-symmetric wave function is a wave function in which on interchanging any pair of identical particles there is no change of sign of the wave function. That is already we have seen is a symmetric wave function. So option 2 is the correct one, that is on interchanging any pair of identical particles, sign of wave function changes. So this is the actual definition of this anti-symmetric wave function. Then 42, a particle which are identical and indistinguishable with 0 or integral spin. So 0 into h cross or 1 into h cross, etc. But the particles which are identical and indistinguishable with 0 or integral spin, all these particles are called as bosons. So bosons have all these parameters, or bosons are the particles which are having all these type of properties. Then question number 43, particles which are identical and indistinguishable with odd, half and integral spin, and all these are called as the fermions. So we know that bosons undergo Bose-Einstein statistics, whereas fermions distribute according to the Fermi-Dirac statistics. So distribution of particles, that is based upon different types of statistics. Based upon that the classification of particles also can be done. Then question number 44, which of the following properties of bosons? So they are identical, they are indistinguishable, they have 0 or integral spin. So all these three are the properties of this boson type of particles or classification. So option 4 is the correct option for question number 44. Question 45, which of the following are the properties of fermions? So here also, first one, they are also identical, they are indistinguishable, they are 0 or integral spin, and all of the above. Actually here these particles are indistinguishable as well as identical, and here we should have this option 3 would have been odd, half and odd integral spin, like 1/2 into h cross, 3/2 into h cross, 5/2 into h cross. So all these particles which are having this half and odd integral spin, they are identical and they are indistinguishable. Then these particles are called as the fermions. Only the difference here is they go by Fermi-Dirac statistics, as well as the Fermi exclusion principle is to be obeyed by these particles. That's why all such particles are called as Fermi particles. Then question number 46, which of the following particles follows the Maxwell-Boltzmann statistics? So here both fermions and bosons do not follow this type of statistics. So electrons are basically fermions, so they undergo Fermi-Dirac statistics. Photons are the bosons, so they go for these Bose-Einstein statistics. Ideal gas molecules are the particles or the molecules of the entity which satisfy this Maxwell-Boltzmann statistics, and therefore option 3 is the correct option for this question number 46. Then question number 47, which of the following particles follow Fermi-Dirac statistics? As our earlier case we have seen, electrons are the fermions, so they must obey the Fermi-Dirac statistics. Photons are bosons, they will go for Bose-Einstein statistics. Ideal gas molecules obey this Maxwell-Boltzmann type of statistics. So first option is the correct option for question number 47. Then 48. Which of the following particles follow the Bose-Einstein statistics? So here the photons are the bosons, Bose type of particles, and therefore they are supposed to obey Bose-Einstein statistics. Electrons will undergo for FD statistics. Ideal gas molecules will go for Maxwell-Boltzmann statistics, and therefore option 2 is the correct option for question number 48. Then question number 49. The number of particles in a given quantum states of Fermi-Dirac statistics are, again here this particular statistics is the particles which obey or which get distributed according to Fermi-Dirac statistics. These particles have to satisfy the principle which is called as Pauli's exclusion principle. And that principle states that these are the particles of which are supposed to stay only one in any given energy states, and that's why 2 is the correct answer for this question number 49. That principle tells that in any accessible energy state, the fermions can occupy only one particle can occupy that type of state. So that is called as Fermi's exclusion principle. So Fermi-Dirac statistics, the particles which are obeying Fermi-Dirac statistics, they have to obey this Pauli's exclusion principle too. And the last question 50. The number of particles in a given quantum state or for Bose-Einstein statistics is here, as I said earlier. So there is no restriction upon how many number of bosons can be accommodated in a single energy state, and that's why option 4 is the correct option for this question number 50. So friends, these are the few very basic questions on this chapter number 5, 4, 5 and 6. So in the first video we have gone for chapter 1, 2 and 3. In the second video we have seen very basic fundamental multiple choice questions which are based upon very fundamental basic concepts of the statistical mechanics. I hope both of these videos might be appreciated by all students. Apart from that, they will be found to be very useful for answering the questions or the multiple choice of questions that will be asked in the examination or the forthcoming examination. So very soon we'll come along with the third video, which is again based upon some difficult questions on this statistical thermodynamics and statistical physics later on. So thank you for patience listening once again.